this session. Okay, so then let me do some problems here, and let me start with problem number 5 on page 305 in your textbook. So this is number 5. Don't want that color. I want black. I want to get rid of that. All right, so this is problem 5 on page 305. What this problem says is that a price-taking firm's variable cost function is Q cubed, where Q is the output per week. It has a sunk fixed cost of $3,000 per week. Its marginal cost, which I can get from the variable cost, its marginal cost is 3Q squared. And the question is, what is the profit maximizing optimal Q given a market price of 243? All right. So this first thing I want to note here is that whenever a cost is sunk, ignore it. Always ignore sunk costs because they are history. They are costs that have been made and cannot be recovered. And for that reason, they should not enter into any decision making. Now, this is true when we look at, maximizing choices for firms, but it's also true in decision making in general in your life, because people tend to get hung up on sunk costs. I give the example of Afghanistan. It's tragedy for lots of people. But one of the arguments for staying in situations like Afghanistan is that we've sacrificed too much blood and treasure to leave now. But those are sunk costs. Before you undertake any more blood and treasure, you need to decide whether you're going forward, your expected outcome merits that. You can't take into account that which is already gone and cannot be recovered. Now, keep in mind that a sunk cost is a cost that's already been made. The cost is never sunk before it's made. But you can recognize that if you do make a cost, you bear some cost in the future that will be sunk after it's made. It's a marginal cost right now, but it becomes sunk after it's made. So you need to keep that in mind. But good decision making depends on the principle that sunk costs are ignored. I think I gave the example in one of my lectures of buying a can of paint, having a custom color mixed, and then deciding you don't like it. Well, that's sunk. So the fact that you have a can of paint there that you don't like shouldn't enter into your decision as to whether or not you want to buy a different can of paint, whether that's worth it to you to get the color you like. So anyway, that's my digression on sunk costs. So for this firm, we are going to ignore the sunk cost. So that's how I'm going to draw that. So the only thing we're going to worry about here is the variable cost. And so my profit maximizing rule is to choose Q such that marginal revenue, in this case for a price-taking firm, is price. Marginal revenue is equal to marginal cost. So in this particular case then, what we have is price is equal to 243. I have marginal cost equal to 3Q squared. I'm going to set that equal to 243. So that tells me Q squared is equal to 81. And that tells me then that Q star will be equal to 9. So this firm would maximize profits by producing 9 units of output. Now, what would the profits be? Well, I'd have to go back, and I know that revenues then would be price, 243, times Q, which is 9, minus costs. Now, here, my sunk fixed costs are actually going to be relevant, so I have to subtract away 3,000 for the sunk fixed costs, and then the variable costs would be 9 cubed. So let's see what that would work out to. 9 times 243. Keep in mind, I make a lot of dumb mistakes when I do arithmetic. 2187 minus 3,000 minus 9 cubed, 729. So that tells me that profits are going to be negative. So what should the firm do? The firm should shut down. Shouldn't produce anything because, no, I take that back, because I made the mistake I was just talking about. It's taking into account its sunk fixed costs, but its profits are going to be negative. Nevertheless, the firm still produces 9. So its profits are going to be what? 2187 minus 3,000 minus 729 minus 1542. So its profits are going to be negative 1542. So it's losing money, but its avoidable cost is 729 Q cubed. So that it's going to still be making, to offset those $3,000 in revenues less avoidable costs, which you'll notice is what we define as producer surplus, is equal to 2187 minus 729, 1458. So it's able to offset 1458 of its $3,000 sunk fixed costs by producing 9 units. If it produces 0 units, its profits would be minus 3,000. And it would prefer profits of minus 1542 to profits of minus 3,000. Now, let me look at problem 6. It builds on this. Problem 6 on page 306 says, in problem 5, what is the firm's supply function when the $3,000 fixed cost is sunk? So once again, it has a sunk fixed cost equal to 3,000. Now in the short run, I ignore the sunk fixed cost. But as I say, in the long run, whether or not we undertake this cost again or not is a decision we will make later on. So the cost has not yet been sunk. So in the long run, that cost would actually be then an avoidable cost. But in the short run, once made, that cost is sunk. So this firm's supply curve, so what we're looking for here is this relationship between the quantity and price. And so here's what I know. I know all my avoidable costs are variable costs. So I have my variable cost, which is variable cost is Q cubed. So variable cost, we said, was Q cubed. That means average variable cost would be Q cubed divided by Q, will be Q squared. And I have a marginal cost, we said, was 3Q squared. Now, minimum average variable cost or minimum avoidable costs here, which are all variable costs, will occur where average variable cost is equal to marginal cost. And this can only hold if Q equals 0. All right, so the firm will produce for any positive quantity of Q, or any price above minimum average avoidable cost, which is, in this case, equal to minimum average variable cost, which is 0. So for any positive price the firm will produce. So its production rule is marginal cost, 3Q squared, will be equal to price. So I'm going to set those equal. And I'm going to solve for Q. So what do I got? I've got Q squared equals P over 3. So that means my supply curve relationship will be Q is equal to the square root of P over 3. And this is for any price greater than 0. So this is the supply relationship I'm looking for. So if price was 9, for example, or I better make that 27, if price was 27, that would tell me then that Q would be equal to 3. Now the question goes on, and you know, once again, I'm completely ignoring this sunk fixed cost. The question asks though, what if, rather than being sunk, the fixed cost is avoidable? So if there is an avoidable fixed cost equal to 3,000, how does that change the question for us? So now we need to take this into account. My avoidable costs, my total avoidable costs, are going to be the sum of fixed costs, the avoidable fixed costs, plus variable costs. It's a little different problem. Now I need to find, you know, I've got average avoidable costs, which are going to be equal to 3,000 over Q plus Q squared. And if my firm cannot cover its average avoidable costs, then it might as well shut down because it's losing money against what would otherwise be avoidable. Now, how do I find minimum average avoidable cost? Well, as always, minimum average avoidable costs occurs at Q, where average avoidable cost is equal to marginal cost. So the first thing I have to do is I find Q, where that minimum average avoidable cost occurs, and then I use that value to identify the value of average avoidable costs at their minimum. So what do I have? I've got 3,000 over Q plus Q squared. That's my average avoidable cost. I'm going to set that equal to marginal cost, which we said was 3Q squared. All right, so I've got average avoidable cost set equal to marginal cost. So what do I have here? I have 3,000 over Q is equal to 3Q squared minus Q squared, so that's 2Q squared. So I get 3,000 over 2 is equal to Q cubed, or 1,500 is equal to Q cubed, and that is equal to 11.45. So this is the value of Q at which minimum average avoidable cost equals 0, but what I really want is the value of average avoidable cost at their minimum. So I'm going to find that by dividing 3,000 by 11.45 and adding to that 11.45 squared. So what do I have? 3,000 divided by 11.262 plus 11.45 squared, 393. All right, that is the minimum point on the minimum average avoidable cost curve. So, here's what I have here. I've got Q and P. I have marginal cost, which we said was 3Q squared. So marginal cost is something like this. This is my marginal cost curve, but I'm actually graphing the inverse of that. And now I have a $3,000 avoidable fixed cost, which gives me, this is actually closer. I don't like the way I do that. Try it again. And this occurs minimum point at 11.45. And that corresponds to a value of 393. And now my supply curve for the firm will be the marginal cost curve for any price greater than 393, but 0 for any price less than 393. So I go back to my price equals marginal cost. And again, I solve. I had Q is equal to Q over 3 to the 1/2 square root. And this is for price that is at least 393. For any price less than 393, the firm would choose to shut down. So this becomes my supply relationship when there is a avoidable fixed cost of 3,000. So I have to always figure out, are my fixed costs avoidable or are they sunk when I do these problems? And whenever they're sunk, you just ignore them. Forget all about them. All right, let's do another problem here. Let's do problem 7 on page 306. Number 7 on page 306. Now this is Dan's Pizza. Dan's cost of making pizzas, we're told, is equal to 4Q plus Q squared over 40. Q squared over 40. Now looking at this, I note that every term in this cost equation varies with Q. So his costs are all variable. He has no fixed costs. So I don't have to worry about it. So this entire thing, since it's all variable costs, is avoidable. So from this, then, I can glean that Dan's marginal cost is equal to 4 plus Q over 20. Now, just for the sake of making things easier later, this is also the same as 2Q over 40. And Dan's, we said that Dan's variable cost is the same as this cost, which is 4Q plus Q squared over 40. This is also equal to Dan's total avoidable costs. One and the same. So that average avoidable costs, in this case, are going to be equal to average variable costs, which are going to be equal to 4Q over Q, which is 4, plus Q squared over 40Q, which is just Q over 40. Now, I need to find those. Where does this thing reach its minimum? Well, by inspection, I can look at that and say, since when Q is equal to 0, it's 4. And whenever Q becomes positive, minimum average avoidable costs in this case are going to be equal to 4. But I could have also found that if I just set this, 4 plus Q over 40, if I set that equal to my marginal costs, which are 4 plus Q over 20, note that these 4's cancel. The only way Q over 40 can be equal to Q over 20 is if Q is equal to 0. So this tells me that Q equals 0 at minimum average avoidable costs. And so if I stick a 0 in, I've got minimum average avoidable cost is equal to 4 plus 0 over 40, which is just 4. So Dan's going to have to get a price of at least 4 for his pizzas to consider making any positive quantity of pizzas. Now, what is Dan's supply function is the question. Well, Dan's supply function, as always, is going to be, he's going to equate marginal cost to price for any price greater than or equal to minimum average avoidable cost. That's every competitive firm's supply function, always. In every case, Dan's no different, unfortunately for Dan. So what do I need to do? I need to take Dan's marginal cost, which we said is 4 plus Q over 20. And I'm going to set that equal to price, which is Dan's marginal revenue. So, and my supply function is always going to be Q as a function of price. So that tells me then that Q over 20 must be equal to P over P minus 4, or that Q will be 20P minus 80. Now note at a price of 4, Dan sells 0, but once the price moves above 4, Dan sells positive quantities of pizza. So this will be Dan's supply function. P will be equal to Q. Q will be equal to 0 for any price less than 4. This needs to be a 4 here. All right. This is Dan's supply function when he has no avoidable fixed costs. So the question goes on, what if Dan has an avoidable fixed cost of $10? Okay, so now that changes our calculus here. If Dan has an avoidable fixed cost equal to $10, Dan's avoidable cost function, avoidable total cost, will be equal to that 10 fixed value plus then the 4Q plus Q squared over 40, the variable cost portion. So this becomes Dan's avoidable cost function now when we include the avoidable fixed costs. Then average avoidable costs will be equal to 10 over Q plus 4Q over Q is still 4, plus Q squared over 40Q is now Q over 40. The addition of a fixed cost does not change marginal cost, because marginal cost is the change in cost, which can only arise from variable cost. So marginal cost is still 4 over Q over 20. 4 plus Q over 20, which I said was same as 4 plus 2Q over 40. So I'm going to find minimum average avoidable cost by equating these two expressions, solving for Q and then sticking that in my average avoidable cost equation. So I've got 10 over Q plus 4 plus Q over 40 that I'm going to set equal to 4 plus 2Q over 40. The 4s are going to cancel. So I end up with 10 over Q is equal to 2Q over 40 minus Q over 40, which is just Q over 40. Or I get Q squared equals 400, or Q equals 20. So Q equals 20 when average avoidable cost reaches its minimum. So minimum average avoidable cost then would be 10 over 20. I should say AAC, clean this up. Minimum average avoidable cost then will be equal to 10 over 20 plus 4 plus 20 over 40, which is 1/2 plus 4 plus 1/2 equals 5. So minimum average avoidable costs occur at a quantity of 5 and are equal to, at a quantity of 20 and are equal to 5. So let me draw these. What do I have here? I've got my marginal cost, which is 4 plus, what do we say? Marginal cost was 4 plus Q over 20. So here's my marginal cost curve. Now I have an average avoidable cost curve. Which reaches its minimum here at 20. And a value of 5. So once I add, you know, this curve here, this we said was Dan's supply curve when Dan had no avoidable fixed costs. But when Dan has avoidable fixed costs, now he needs a price of at least 5 to produce a positive quantity. So this becomes Dan's supply curve with positive avoidable fixed costs. So now Dan's supply curve is going to be Q is equal to 20P minus 80. Did we lose my, why that happened? Can you guys see this at all? Are you still there?
Yep, we can.
You still see my iPad, or what do you see?
We can still see your iPad. We just see that it's
just trying to connect.
Yeah.
All right.
We see the pop up, and that's about it.
So can you see the iPad now?
Yes.
Yes.
Okay, thanks. So anyway, supply curve now is Q20 minus P for any price of 5 at least. And you can see 20 times P would, you know, at a price of 5 is 100 minus 80, which is 20. And Q is then equal to 0 for any P less than 5. So this is, you know, Dan's supply curve with these avoidable fixed costs. If those fixed costs have been sunk, we would have had this supply curve. But since they're not sunk, since they're avoidable, we end up with then this supply curve, starting right here. So if I were to actually draw that, you know, by itself, I would have something that looked like this. Right here at 5. And the supply curve then would be 0 for any price less than 5. And then at quantity of 20 and 5, then it takes off, and it's the marginal cost curve. It's always the same way, every single time. Whenever you want to find a supply curve, short run supply curve, you take a look at, you know, you establish what the total avoidable costs are, and you find minimum average avoidable costs by setting average avoidable costs equal to marginal costs, solving for Q, sticking that value of Q back into the average avoidable cost equation, and determining then exactly what the value of average avoidable costs is at that quantity of Q. And then you take the supply curve, you take the marginal cost curve as supply curve from that point on. So number 8 says, what if, still working with Dan here, what if Dan's cost increases by $2 per pizza? So cost increases by $2 per pizza. And that means now that Dan's cost function will be 6Q plus Q squared over 40. Well, that means marginal cost now is shifted to 6 plus Q over 20. So the marginal cost curve has shifted up. And if Dan has no fixed costs, which looking at this says he doesn't, every term in his cost equation varies directly with Q. So Dan only has variable costs. So his avoidable costs are going to be equal to his variable costs. And so, that's back to 6Q plus Q squared over 40. So his average variable costs, which are in this case, back again to that, will be 6Q over Q plus Q squared over 40Q. So that's going to be 6 plus Q over 40. Now, once again, setting marginal cost equal to average variable cost, the 6's cancel. And the only way Q over 20 can be equal to Q over 40 is if Q is equal to 0. So minimum AAC occurs at Q equals 0. Sticking that in, we know that minimum AAC then is equal to 6 plus 0 over 40. And so it's just 6. So the supply curve, when its costs go up by $2, and there are no avoidable fixed costs, was before, had that intercept of 4, and it had a slope of, the inverse supply curve has a slope of 20. Now, when its costs go up to $6, the supply curve just shifts up in a parallel fashion by the change in Dan's unit cost of pizzas, as you would expect. So the marginal cost curve shifts up by 2, so does the supply curve. How will the supply function change? Okay, so it just shifts up by the amount of the unit price increase. In this case, $2. Now, number 8. No, number 9. Number 9 says, consider again problem 7. If Dan's avoidable fixed cost increases from 10 to 22.50. So avoidable fixed cost increases from 10 to 22.50. So in this problem here, we did a change in Dan's variable cost of $2. And number 9, we're doing a change in Dan's avoidable fixed cost from 10 to 22.50. So in this particular case, Dan's total cost function will be equal to 22.50 plus 4Q plus Q squared over 40. And this is an avoidable fixed cost. So that tells us that Dan's total avoidable costs will be equal to 22.50 plus 4Q plus Q squared over 40. So that tells me now that average avoidable costs have changed from rather than no longer 10 over Q, but 22.5 over Q plus 4 plus Q over 40. So we have to find now the minimum point here. So once again, marginal cost hasn't changed. The only change was in a fixed cost. So marginal cost itself, which only depends on variable costs, did not change. So I'm going to set my average avoidable cost equal to my marginal cost, which is Q over 20, right? Let me restate this as 4 plus 2Q over 40. So I have a common denominator there. So 4s are going to cancel as before. So I end up with 22.5 over Q plus Q over 40 is equal to 2Q over 40, or 22.5 times 40 is equal to Q squared. I skipped a step here. my algebra. So I've got 22.5 over Q is equal to 2Q over 40 minus Q over 40, which is just Q over 40. So I end up with 40 times 22.5 is equal to Q squared. And in this case, I've got then 900 is equal to Q squared. So Q is equal to 30. So now, with the increase in avoidable fixed cost, the minimum point occurs at Q equals 30 rather than Q equals 20. So you can see the supply curve is going to shift up and to the right, as it turns out. So now, with this, I want to find, I got average avoidable cost now is 22.5 over Q. So minimum average avoidable cost will be equal to 22.5 over 30 plus 4 plus 22.5 over 30 over 40 rather. Is that right? Did I do this right? 22.5 over 30. This is 22.5 plus 4 plus 30 over 40. This should be. There we go. So what is this? 22.5 divided by 30 is 0.75 plus 4 plus, that still doesn't look right to me, 30 over 40, it's Q over 40. All right, I'll buy it. Q over 40, you got to believe what you write down, I guess, don't you? Q over 40, 30 over 40, so that's 0.75. So that's 5.5. All right. So now, minimum average avoidable cost arises at 5.5. Note marginal cost, again, didn't change. So we're back to Dan's supply function is going to be equal to 20p minus 80 for P at least 5.5, and Dan will shut down for any P less than 5.5. All right. So if we were to draw that, let's come back to Dan's supply function here. We didn't do that one. Somewhere we did. We are. So now Dan's minimum point here occurs at Q equals 30. Minimum price of 5.5. So we have a new average avoidable cost curve associated with the new higher avoidable fixed cost, reaches its minimum here at quantity of 30. And a price of 5.5. So did we finish that up? So this supply relationship, when drawn out, says that Dan's supply curve stays the same. It's the same marginal cost curve, but this minimum point shifts up and to the right, so that Dan's minimum quantity and price have both increased as a consequence of an increase in Dan's avoidable fixed cost. So that's how I go about all of these problems, these supply side, finding these competitive firm supply curves. It's the exact same thing every time. Identify all avoidable costs, and they may be just variable costs, but I totally ignore any sunk costs. I identify all avoidable costs. I find minimum average avoidable costs by first solving for the value of Q at which that occurs, and I do that by setting marginal cost equal to average avoidable cost. Then when I find the value of Q at which minimum average avoidable cost occurs, I stick that into my average avoidable cost function to determine what the actual value of average avoidable cost is at that minimizing value. And that's my minimum average avoidable cost. And my firm has to get at least that in order to operate. And it uses its marginal cost curve then for all prices above that as its supply curve. But what I do when I express the supply curve, I set price equal to marginal cost and then solve for Q in terms of price. And then solve for Q in terms of price. And that gives me that firm level supply curve, or the marginal cost curve expressed as Q as a function of price above that minimum average avoidable cost. Now let me change gears for just a second here and talk about producer surplus. Producer surplus, the definition of producer surplus is revenue minus total avoidable costs. It's different from profit if there are any sunk fixed costs in the production. Now, remember we said that profit was equal to revenue minus total costs, which is revenue minus sunk fixed costs minus avoidable fixed cost minus variable cost. And let me rearrange this a little bit. Let me say this is equal to revenue minus sunk fixed costs minus, well, avoidable fixed costs plus variable costs is just avoidable costs. So this is revenue minus sunk fixed costs minus avoidable costs. And restate this again. This is revenue minus avoidable costs minus sunk fixed costs. So profit is just producer surplus minus sunk fixed cost. Now, in the short run, we're saying that a firm will only operate if it can at least cover its avoidable costs. That's the same thing as saying that the firm will only operate if its producer surplus is non-negative. So the firm has to get at least its avoidable costs from operating, or it has to get non-negative producer surplus. Obviously, any producer surplus that this firm earns will be revenues that offset their sunk fixed costs. And so profit equals zero when producer surplus is exactly equal to sunk fixed costs. So the firm is generating enough revenues to exactly cover its sunk costs. Then its profits are zero. Now, when I think about calculating producer surplus, there's two ways I need to think about this. Suppose that there are no avoidable fixed cost. So there's no avoidable fixed cost. All costs are variable cost. So I think about drawing out this firm's costs here. And let me think about just focusing on the marginal cost curve. So here's the marginal cost curve for this firm that has no avoidable fixed costs. And let me think in terms of what am I looking at here? Now, producer surplus for this particular firm is going to be equal to revenues minus variable costs, since there are no avoidable fixed costs. So producer surplus is going to be total revenues minus total variable costs. Well, what are total variable costs here in my drawing? Well, the first unit cost me this much to make. The second unit cost me this much to make. the third unit cost me this much to make, the fourth, and so on. So each of these additional units, the cost of producing that additional unit is captured by the marginal cost of that unit. So if I were to add up the cost of the first unit plus the cost of the second unit plus the cost of the third unit, fourth unit, and so on, I would have the total cost of producing 4 units. The sum of these 4 marginal costs is the total variable cost, I should say, of producing these 4 units. So let's just say that at a given price here, the firm, maximizing its profits, chooses quantity of 10 because that's where price is equal to marginal cost. Well, what's the total cost of producing these 10 units? Once again, I add up all of the marginal costs and I get there. So total variable cost here would be the area underneath the marginal cost curve. So right there would be my total variable cost. And what's my total revenue? Well, I know my total revenue is price times quantity. So this rectangle here is my total revenue. Well, producer surplus is revenue minus variable costs. So that leaves this area here as the difference between total revenue and total variable costs. So, geometrically here, this area above the marginal cost curve and below the price line is producer surplus. So that's how I would find it on a drawing if there were no avoidable fixed costs. Let me go real quickly here. I know we're running out of time. Suppose that we have positive avoidable fixed costs. They're positive. Well, that means then that I've got some kind of a relationship here that tells me, my firm has to get this price at a minimum. That's its base price. And that corresponds to this quantity where average avoidable costs are at their minimum. So I know average avoidable costs are at their minimum right here. Avoidable costs are at their minimum right here. So that means that this area right here is equal to avoidable costs. All right. Since this is average avoidable cost, price times average avoidable cost must be avoidable cost. Okay, or Q times average avoidable cost, I should say, is equal to avoidable cost. So this area right here would be my total avoidable costs, which would be the sum of, let me put my marginal cost curve in here, which would be the sum of total variable costs. So this would be total variable cost. And this area here then would be my avoidable fixed cost. Now, once my firm gets to Q, this particular Q at this particular price, it has covered its avoidable fixed costs. And they don't change because they're fixed. So if my firm produces more than this level of Q, then the additional costs, the increments in cost, would just be the marginal cost of those additional units. So if the market price was P and my firm maximized profits by producing at this Q star, then my firm's total avoidable costs would be this area here for the first Q sub bar units, and then this area here for the additional units, Q star minus Q sub bar. So this area now, this rectangular portion plus this portion become my total avoidable costs. Revenues are exactly as before. Revenues are this rectangle. So that's R. So that means the remainder then will be my producer surplus. Total revenues minus total avoidable costs. Always the same. So each of these firms, because the way I've drawn them, they have positive producer surplus, regardless of what their sunk fixed costs look like, these firms will choose to operate. Whenever they have positive producer surplus, they're going to operate. All right, I see we're out of time here, so let me stop share. Any questions, anybody?
Not particularly, but I appreciate the assistance.
Yeah, I mean, does it make sense? The algebra?
When it comes down to explaining it, yeah, but I'll need to study some more on my own time to make sure I actually completely understand it. But yeah, I really do appreciate it.
Yeah, find some people to explain it to. I mean, you know, when you can explain something and they understand what the heck you're talking about, you got to know it, you know. So the more you guys could actually interact in that course room or however other you might be able to do it, Zoom, the more you guys can explain stuff to each other, the better off you are. All right?
All right.
Everyone,
Thank you.
okay, remember, think about what you want to review for the exam on Wednesday before we meet. All right?
All right. Thank
Yeah.
you.
Yep. Anybody else? No? Okie doke. I'll see you then Wednesday. Bye-bye.
See you then.
Bye-bye.